So we're going to be sending 5, irrespective of the number of ovaries we added. Now, it's important to state here that when you are asked to send 4 capsules, you add an overage of 2 to get an even number. So we're asked to send 5 capsules here. So we add an overage of 1 to get an even number of 6 capsules. So remember, now these capsules comes in different sizes, and these sizes comes in different code. Now this capsule number 00, it means there's a capsule size will contain 950 milligram. So this capsule size will contain 950 milligram. And according to our question, they say we should use capsule number 1, means 300 milligram. It means one capsule is going to contain 300 milligram of our medications. Now, remember we've added this overage. Now, it then means, and we are sending, and our prescription is ATS, atropine sulfate 0.25 milligram. It means one capsule should contain an ATS of 0.25 milligram, right? And we know in the lab, the least weighable weight that we can measure in the lab is 100 milligram, right? So what do? We use serial dilution. We make use of a diluent, and the diluent which is usually used in capsule preparation in the lab is usually fresh lactose, or we can use starch, but provided the one that is given to you, you make use of that. So we're going to begin immediately. So since one capsule should contain 0.25 milligram of ATS, 0.25 milligram of ATS, 6 capsules will then, we are trying to note the total weight of atropine sulfate we are going to use for these 6 capsules. So 6 capsules will contain 6 multiplied by 0.25, which is going to give us 1.5 milligram of ATS. So the total atropine sulfate we are going to be using is 1.5 milligram. Now note also, remember that I told you about the capsule size, that this capsule number 1, can only contain 300 milligram, right? So if one capsule will contain 300 milligram, 6 capsules contain 1,800 milligram. 1,800 milligram. So at the end of the day, our total preparation should be 1,800 milligram, right? It's important you know this and keep it aside as we go to our question. Now, remember how I told you that because the weight of this ATS cannot be weighed, that the weighing balances we have in the lab is not sensitive enough to weigh that minute quantity of ATS, a total of 1.5 milligram, which we are going to be using for the 6 capsule. We have to do serial food dilution, and we must begin from having 900 milligram of ATS. Now remember, ATS, atropine sulfate, is a poison, and this poison are gotten from the poison books and recorded in the poison book. You must state this in your procedures when you're writing. It shows the examiner that you actually know what you're doing. So how will we start? We start from 100 milligram of ATS. You say that 100 milligram of ATS was weighed from the poison book, into your mortar and pestle. It was recorded in also in the poison book. ATS plus 900 milligram of your diluent, which is your fresh lactose, or fresh lactose. Now, I must state that in preparing this preparation, you might have to make use of more than one mortar and pestle in the lab, depending on the weight of the atropine sulfate you have. You might need, this question might probably lead us. Let's solve on as we go on. So in this, we now have 100 milligram of ATS and 900 milligram of fresh lactose is now weighed into a mortar, and it's now titurated to a homogeneous mixture with sweet. So 100 milligram of ATS or 900 milligram of fresh lactose will give us 1,000 milligram of mixture. Let's call it A, right? Let's call it mixture A. Remember, what we are trying to do is to get a mixture of to get a weight of this mixture, so that will give us 1.5 milligram of lactose. So what do? We now say that since if 100 milligram, 1,000 milligram of ATS of mixture A contained 100 milligram of ATS, how many milligram of mixture A would give us 1.5 milligram of ATS? So we cross multiply, x is now equals to 1,000 multiplied by 1.5 divided by 100 to give us 15 milligram. Remember, I told us that the least the least weight, 15 milligram of mixture A. What this means is that when we get 15 milligram from this mixture A, which is a combination of 100 milligram of ATS and 900 milligram fresh lactose, would have 1.5 milligram of ATS. So 1.5 milligram of ATS is in this 15 milligram of this mixture A. Now remember what I told us, that the least weighable weight that we can measure with the weighing balances in the lab is 100 milligram, right? And 15 milligram is not weighable in the lab. So we do another serial food dilution by getting 900 milligram, by getting 100 milligram of mixture A and add and using a fresh lactose of 900 milligrams. So what do? We now say 100 milligram of mix A plus 900 milligram of another fresh lactose, which you must transfer into a new mortar and paste a new mortar of fresh lactose. Now this mixture will now give us mix B. We'll now call this mix B, right? Remember that when we had 100 milligram of ATS when we had 100 milligram of ATS in 1000 milligram of mixture A, this mixture contained 1/10 of this ATS was 1/10 of the total mixture here, right? So since this thing will now give us 1000 milligram of mix B, 1000 milligram of mix B. Now say that 1000 milligram of mixture B contains 10 milligram, which is the 1/10 of it, of the ATS needs. 10 milligram of ATS. Remember what we are looking for is 1.5 milligram of ATS. That's what we are looking for. So how many milligram of mixture A would contain 1.5 milligram of ATS? And when you do the cross multiplication, you would get a total of 150 milligram of mixture B. What this tells us is that when we get 150 milligram of this second mixture B, which is a total of which is 100 milligram from the mixture A plus 900 milligram of a fresh lactose, when we get 150 milligram of this mixture B, we will get inside it is 1.5 milligram of atropine sulfate, right? So remember that we calculated that our total powder mix is going to be 180 milligram, right? So in this, we have the weight of our ATS we are looking for, right? And we are making use of diluent. So we dilute the rest, 150 milligram of this mixture A, with the difference between 1800 and the 150 milligram. So what we do is, if you don't mind, let me clean here. So what we do is try to get the difference between 150 milligram of this mixture A we've gotten from this 180. So we say 1800 milligram minus 150 milligram of mixture B. So the difference is 1650 milligram of fresh lactose or whatever diluent you are giving to in the lab. So what you now do is, after getting this 150 milligram of mixture A, transfer it into another mortar and weigh 1650 milligram of fresh lactose into that same mortar and titrate it till you get an homogeneous mixture. It's from that homogeneous mixture that's your final preparation that you use to fill up your capsule shells. Remember, we added an average of 1, so you are sending a total of 5. So you fill up 5 capsule shells. Remember, of capsule size number 1, which contains 300 milligram. You necessarily don't have to weigh 300 milligram into each capsule size. You just have to add it until it's filled and cover it with the capsule cap, right? So since we are done with this, we would like us to write our label and now procedure. Before that, let's talk about our procedure. Now, according to what we've done here, our procedure will go with us like after an accurate calculation was done. We now say that 1000 milligram of atropine sulfate was weighed from the poison box into our mortar and recorded in the poison book. So I'm just trying to paraphrase, but you know what to write. And 900 milligram of fresh lactose was also weighed into the same mortar to make mixture A. So you note that you titrated it to an homogeneous mixture of mix. You now take then 100 milligram of mixture A was now weighed out into a fresh mortar, and 900 milligram of fresh lactose was also weighed into the new mortar and titrated in an homogeneous mixture was formed. Then finally, 150 milligram of B, mixture B was then weighed out and transferred into another mortar, and 1650 milligram of fresh lactose was weighed into that same mortar, titrated, and the final preparation was now used to fill up 5 capsule shells and placed in the dispensing bottle, properly labeled and dispensed. So I'm just trying to paraphrase this, but your procedure is what you must have already mastered by now. So this I just link practically with the calculation questions. So our label is going to be like this. You're asked to send 5. So you write 5 at the top. You write the capsule. I remember each capsule will contain 300 milligram because of the capsule number we're asked to send 300 milligram. You now say atropine sulfate, 0.25 milligram. Then the direction, you say it. Direction for use: give 1 capsule at night. Give 1 capsule at night. Then your name, your reg number, the address, the date, right? The date. Now, in the auxiliary label, you are going to write poison with a red pen at the top with the auxiliary label. Then you write poison. Then you write store in a cool, dry place. The auxiliary label is going to be store in a cool, dry place. That's basically it with this capsule. So now over to the next question. Uh, Before we solve our next question, I must note that you must continue to do your serial dilution over and over again till you get a weight that is weighable by the weighing balances in the lab, which the least is 100 milligram. So depending on the kind of question you are given, you might need to do your titration over and over again. And remember, the higher the number of serial dilution you do, the more mortar you use. So some preparation might require you to be using at least 4 mortar. Remember the previous question, we used probably around 3 mortar thereabouts. So this next question talks about preparing amylobacterium sodium 2.5. Now we're asked to make and send 6 capsules. Now 6 capsules. Remember I told us about adding an overage to give us an even number. 6 capsules plus 2, which is our overage, will give us 8 capsules. And remember, for this preparation, 1 capsule must contain 2.5 milligram. And if 1 capsule must contain 2.5 milligram, how many will be contained by 8 milligram? So when we do our cross multiplication, we get 8 multiplied by 2.5, which gives us 8 multiplied by 2.5, which gives us 20. Now, according to our label here, remember we noted the number of capsules that was sent, which is 6. We also noted the weight of capsule shells that we used, which is 250 milligram. Then you make sure to write your poison box at this auxiliary label part, then store in a cool, dry place. And with that, you also write your procedures and how you did your experiment. So over to the next question, the final question. So for this question, we are going to be sending 5 capsules Now we're going to be sending 5 capsules. This is the interpretation of these Latin abbreviations here. We're going to be sending 5 capsules. We're going to be using capsule number 3. Each 3 means 200 milligram. So for the first capsule, one capsule should contain 0.025 milligram. One capsule should contain 0.025 milligram. But before then, when we are sending 5 plus 1, which is our average, we are sending 6 capsules in general. In total, 6 capsules. So one capsule is 0.6. So 6 capsules should give us 0.15 milligram of our poison ATS. Now, 0.15 milligram of ATS is practically unweighable with our weighing balances in the lab. There's no weighing balances in the lab that can be sensitive enough to weigh this weight. So we go to the weight of the capsule. So since one capsule, we are using capsule number 3, which is 200 milligram. If one capsule is 300 milligram, then 6 capsule should be 1.8 milligram, 1,800 milligram, right? So we then go on to begin our serial food dilution. We'll say 100 milligram of ATS plus 900 milligram of your diluent, which can be lactose or starch. Let's call this lactose. Depending on the one you're giving in the lab, you make use of them. So this, after titrating this in a mixture, we get our fixed mixture, which you call mixture A. Now, mixture A is 1,000 milligram. 1,000 milligram of mixture A contains 100 milligram of our poison, 100 milligram of ATS, and we are looking for 0.15 milligram of ATS. So how many milligram of this mixture would give us 0.5 rather, 0.15 milligram of our hydrogen sulfate. And when we cross multiply that, we're going to be getting 1.5 milligram of mixture A. Now, 1.5 milligram of mixture A is practically unweighable. The weighing balances in the lab, right? But if we can be able to get 1.5 milligram, it means 1.5 milligram contains 0.15 milligram of ATS. Now, 1.5 milligram is not weighable. Then we continue our dilution. We now say 100 milligram of mixture A is then taken into a fresh mortar, and 900 milligram of fresh lactose was taken. So we now say 100 milligram of mix A plus 900 milligram of lactose. Remember, now into another mortar. Now give us, after titration, this will give us one mixture B, right? Now in this thing we now have 1,000 milligram of mixture B. Now remember what I told you about the 1/10 of the previous weight of the ATS. So 1,000 milligram of mixture B will contain 1/10 of the weight of this poison, which is 10 milligram. Contains 10 milligram of ATS. Contains 10 milligram of ATS, and we're looking for 0.15 milligram of ATS. So X here. So when we do this cross multiplication, what we will be getting is X now be equals to 15 milligram of mixture B. Again, this weight is not weighable. or there's no way imbalance in the lab that is sensitive enough to get 50 milligram of mixture B. So we continue our dilution. So permit me to clean this side. Hope you've noted this up to now. So we now say 100 milligram member of mixture B plus 900 milligram of a fresh diluent of lactose. I have 1000 milligram of, let's call this mixture C, right? So this 1000 ml of mixture C will also contain 1/10 of the weight of the previous weight of the now sorry, this 1000 milligram of mixture C will contain 1/10 of the weight of the previous weight of poison in mixture B, which will now be 1 milligram, right? This 1000 milligram of mixture C contains 1 milligram of our poison of ATS. So remember we are looking for 0.15 milligram. So 0.15 milligram of ATS contained in what weight of our mixture C, which gives us 150 milligram of mixture C, right? Remember, this weight is the only weighable weight we've gotten so far. So we are going to stop here, and our final weight, we are going to be finding the difference between our final weight, which was 1/8 minus this. So 1/8 minus 150 give us 1650 milligram of diluent. So what we do is now we now take 150 milligram of from mixture C, 130 milligram of mixture C, take it into another mortar. This is now your fourth mortar, and weigh 1650 milligram of your fresh diluent which is could be lactose or starch. Then you titrate it evenly. It's now from that final weight, which is going to be 1800 milligram. After we weighed 180 of diluent and 150 of mixture C, 1800 milligram is total weight. It's now from this mixture that we use to fill up five capsule shells. Remember, 5 capsule shells because we added one as overage. You now use it to fill up 5 capsule shells and now dispense your products and follow the procedures and write the procedures as we've written them so far. So that's it. And for the label, I'd expect you to write the label for this particular procedure. And so that's that for our capsules. And thank you for being in this video so far. Thank you.